Welcome everybody to the Liquid Gas Europe webinar today, entitled Defossilising European Heating and Transport with Renewable and Recycled Carbon DME. First of all, I'd just like to apologise for those of you who were expecting my colleague Ava. Unfortunately, Ava is not very well, so she's delegated the task to me. I hope that doesn't disappoint you too much. First of all, I'd like to start with a short introduction to the other speakers in this webinar. We have Rebecca Boudreaux, the President and CEO of Oberon Fuels. We have Sophia Haywood, Advocacy and Communication Manager at Dimeta. Christopher Kidder, Executive Director, International DME Association. And Chris Goggin, Operations Director of Rinnai. Before we proceed, I'd just like to mention that you can ask questions via the chat button at the bottom of the screen, and if you do so, then we will endeavour to ask those questions during the course of this webinar. And of course, the webinar will be recorded, so you will be able to view this in the future. First, I'd like to start by setting the scene, outlining the importance of the defossilization of liquid gases. It's very important to note that there are approximately 50 million people in the EU who live in rural areas. And of those 50 million people, I'll correct myself there, 50 million households, not 50 million people. It equates to about 130 million individual citizens. So of those 50 million households that are not connected to the grid, 36% of those households in rural areas are old buildings, and this is very common for rural buildings, and they were often built prior to the thermal regulations of the 1970s. So solutions that are appropriate for urban areas are not always or often inappropriate for rural areas. That's one reason why we need liquid gases in rural areas. Also in rural areas, electricity networks are less developed than they are in urban areas. So problems associated with the supply of electricity also mean that we need alternative options for defossilizing heat in rural areas. So that's a bit of the background for the importance of renewable liquid gases in rural areas. There are obviously other fuels that are available, and some of those fuels are very high carbon, like coal and oil. So in addition to replacing fossil liquid gases with renewable liquid gases in rural areas, we also need to take the opportunity to convert other fuels that are high carbon to renewable liquid gases. So that's essentially the background, the importance of renewable liquid gases to the defossilization of buildings in rural areas, both domestic and non-domestic buildings. Now I would like to introduce Christopher Kidder, who's going to talk to us about a renewable liquid gas that I've already mentioned today, renewable and recycled carbon DME. And Christopher, who's an expert on this, is going to proceed to explain what is DME. Thank you, Christopher.
Mute myself. John, thank you very much. The association and I are grateful to Liquid Gas Europe for this opportunity to speak to this group today. Despite the incredibly dynamic number of announcements and events and progress over the past several years related to DME, and in particular to renewable DME, we're aware that there's a lot of unfamiliarity with the topic, both traditional and renewable DME. And we thought it would be worthwhile just to spend a few minutes on a backgrounder, on a primer, just reminding people of the business case, the very compelling business case for DME, and the applications in which are being pursued right now. First off, a little bit about the IDA. It was founded in 2001. It is the global voice of the DME industry and works to promote the use of DME as a clean and greenhouse gas reducing alternative fuel worldwide. The membership ranges over the entire value chain, from the process technology manufacturers involved in the production of DME, producers of DME, distributors and component equipment manufacturers, and the downstream applications. So the membership currently represents this entire spectrum. And indeed, the board of directors and the executive committee represents all of those as well. We've been working over the past 2 years, engaging in advocacy efforts in both Europe and certainly in California. That was Oberon Fuels, but starting off in North America as well, speaking with decision makers and regulators about DME and introducing the topic to what is largely a crowd that is unfamiliar with the topic so far. The IDA obviously supports the European Green Deal, the objectives, and is fully committed to the 2050 climate neutrality target and the increased 2030 climate ambitions outlined by them. We'll be talking a little bit about the regulatory and the legislative landscape later in this webinar. The IDA isn't alone, though. It works closely and maintains close ties with regional DME associations, primarily in Asia, China, Korea, and Japan, and related industry bodies, uniting those organizations that are most active in the commercialization of and the advocacy for DME. The IDA has long benefited from strong support from both the LPG industry via the World LP Gas Association, and also the methanol industry, DME primarily being made from methanol. This is a long-standing relationship, and I'm delighted. I don't think I'm giving any secrets away, but I believe tomorrow there's going to be an announcement and a signing ceremony in Brussels where our newest strategic partner, the Liquid Gas Europe, will sign a strategic partnership with the IDA. I believe our chair, Soren Jacobsen, is going to be in Brussels for that event. And we're delighted to welcome Liquid Gas Europe as our most recent strategic partner in this endeavor. So what about DME? Like methanol, which is the simplest alcohol, DME is the simplest ether. It's a single molecule that can be produced from a wide range of feedstocks. It's a multi-source, multi-feedstock, multi-application energy source. I think we all know it's very chemically similar, physically similar to propane and butane, and is a gas at room temperature and pressure. This offers and produces a lot of interesting possibilities up and down the LPG value chain, from the equipment used to handle, store, and distribute LPG and possibly DME, to the applications themselves, either blended or in or 100% DME. In terms of transportation applications, its chemical and physical properties make it compatible with existing diesel technology. It's not exactly a drop-in, but with very modest modifications, it can be used in either new diesel engines, heavy-duty, medium-duty, light-duty diesel engines, or with a retrofit, could be used as well. It can also, of course, be blended at up to 20% mass into LPG and used in existing LPG appliances and equipment. And it could also be used as 100% renewable fuel with very modest modifications to the equipment. I think the most dynamic developments are obviously going on now related to renewable DME. I think we're going to hear a lot more about renewable DME and what's going on in several markets from Dr. Rebecca Boudreaux a little bit later. But obviously the impetus here, the attraction here, and the business case here are the potentially large reductions in greenhouse gas emissions compared with diesel, heating oil, and other fuels. The huge reductions in criteria emissions as well, and the fact that it can be made from a variety of available and sustainable feedstocks. In terms of the European objectives, DME offers a very compelling case as a decarbonization enabler, a low barrier to entry, given that DME is available, currently produced in relatively modest commercial quantities, but certainly the announcements we've seen over the past year and a half or so related to the potential production of renewable DME, both in Europe and North America, offers some exciting possibilities and enabling factors for this. GHG emissions up to 85% reduction. I think we're going to hear a little bit more from Dr. Rebecca Boudreaux about that. Some of these numbers initially came out of California and their work there. And then certainly the reduction in criteria emissions with zero sodium oxides, much reduced nitrogen oxides, and zero particulate emission, which is an incredibly important and attractive possibility for the transportation market, the diesel market. Typically, and until now, commercial applications for DME have revolved around DME's use in heating and cooking. This was particularly the case in China, but this was fossil DME. This was DME made from coal to methanol to DME. What we're talking about now in North America and Europe in particular is the enormous and quite practical immediate carbon reduction that could be achieved if renewable DME is blended into LPG for use in heating and cooking, both domestic and industrial. John mentioned earlier, between 40 and 50 million European households currently located in rural areas are simply not connected to the grid. This offers a huge potential with very modest modifications and implementation for the logistics in terms of introducing low carbon renewable DME to these customers. And we talked about the blending as well, up to 20% DME by mass blended with LPG with no modifications to equipment. Again, offering an enormous amount of attractive, practical, and practically immediate benefits to this huge customer base. Renewable DME in industry. This is a huge potential market, obviously also covering heating, cooking, industrial high temperature heating, excuse me. And other very difficult, hard to abate, hard to decarbonize areas, which offers a huge potential, possibly better than many of the electrification options being talked about. Coal or oil-fired boilers could also be replaced with DME boilers. There's been extensive work already done, mostly in Asia, by major manufacturers of boilers using DME, and especially as these fuels are increasingly being phased out, this offers a very attractive and compelling option. And then, of course, transport. This was always initially seen as the initial potential channel to market. Companies, major international global leaders in heavy-duty diesel, such as Volvo, Mack, Ford, Isuzu, have done extensive work, millions of kilometers of demonstrations. And this is still something very interesting. The IDA had its 9th International DME Conference in Switzerland this year for the specific purpose of speaking and seeing some of the work being done by Fiat Powertrain, the global manufacturer best known probably in Europe for Iveco engines. They are doing work on this as well. And with renewable DME offers an even more attractive option in addition to the lack of particulate matter and the reduction in criteria emissions. And then lastly, but certainly not least, and this is something as well, I'm going to mention Oberon Fuels again, where they are leading the drive into this application with DME as a hydrogen carrier. Surprisingly to many, a liter of liquid DME contains more hydrogen than a liter of liquid hydrogen. So this is a very attractive option, and one that, in which they're working with one of the US national laboratories on. And there's a straightforward process that can convert DME back into hydrogen for use in industry, transport, domestic heating, and cooking. That's a brief primer. I invite everyone who's on this webinar to join us for our monthly briefings, where we have people like those assembled today giving updates about this, about recent developments, and more information about the applications, especially for renewable DME. Thank you very much, John.
Thank you for that, Christopher. That was very useful and interesting explanation about DME, which is not new, but the exciting picture you painted with the availability of renewable and recycled carbon DME. Thank you very much for that, Christopher. I'm sure we'll be getting back to you later with various questions that we wish to pose, and hopefully participants in the webinar wish to pose. So I'm now going to move on to Sophia Haywood, who is the Advocacy and Communication Manager at Dimeta. Sophia, over to you.
Thank you very much. So let me just have a go at sharing my screen. Hopefully that is sharing okay. If I could get a thumbs up, that would be great, because a couple of technical hitches already this morning, which I like to bring with me. So what I'm going to talk about today is a little bit, building upon the great presentation just from Chris now, around the fundamentals of DME, the fact that it's an established fuel already, and that it can become even more established with the industry as we transition to renewable and recycled carbon feedstocks, and thinking a little bit more about actually what ourselves at Dimeta are doing in this space, again, specifically around renewable and recycled carbon. So I'm Advocacy and Communications Manager at Dimeta, and Dimeta are doing something that I think is particularly interesting. We're looking at solving problems and creating solutions. So across the world, and indeed specifically in Europe as well, we are facing huge issues around waste and how we reduce waste, how we recycle more, how we change, in essence, I think, the way that we've been approaching this subject for quite some time. So we're going through this process, and I think, looking ahead, looking at the off-grid market and all this opportunity, we're looking to deal with that problem by creating a solution, and that solution is for the off-grid market. There is clear need and demand, as Chris has outlined, for renewable gaseous solutions that can help, whether it's homes, businesses, industries, transport applications, have a just and fair transition to net zero. So, who are Dimeta? You may have heard of us already, you may not have heard of us. We are quite new. We were established in February of this year. We were established as a joint venture between SHV Energy and UGI International. This is a kind of monumentous occasion, really, of industry coming together to not just accelerate the production of renewable and recycled carbon DME, but also about accelerating its adoption and working very closely with industry and key stakeholders to make that happen. So if I could narrow it down to 4 key things that we do, and by far means this is not limited to this, and I'm sure some of my colleagues would definitely agree with that. We're looking at identifying partners and frameworks for developing plans. I'll go on to talk a little bit about our first plant and what we're looking to do in Europe and beyond. We have an ambition to produce 300,000 tonnes of renewable and recycled carbon DME per year by 2027. We will be wholesaling renewable and recycled carbon DME to the LPG market. So again, this is very much focused on giving off-grid areas a just transition to net zero, and also looking to advocate support for the product and promote its adoption. And working with people who are on this call, working with many of you on the webinar, and many people also who aren't on the webinar today. I'm not going to spend too long on this because I'm sure you all don't want the corporate spiel, especially on something like this. But I think it's just important to mention that we work across the whole value chain. So we're covering, from R&D through to project development, commercial supply, myself on the advocacy and communications. But we really are covering a wide range of areas for a new business. So focusing a little bit more, I think, on the subject at hand, defossilising European heating and transport. And I mean, the first time I heard defossilising, I had really no clue what it meant. And I think that a lot of people also will probably be in a similar boat because there's all this new terminology that's coming around. But what it fundamentally comes down to is the fact that there is a real need. And I've just put a little kind of few examples up there for whether it's distilling, I mean, my personal favourite out of all the industries, if I'm being honest, but lots of other industrial applications also that need to, reduce their carbon emissions. That might be, in terms of the transition from LPG to renewables, but also huge amount of businesses, industries, etc., everyone on fuel oil or coal. We really need to work very closely in terms of being able to transition these users onto renewable solutions, and having a kind of one size fits all approach that isn't going to work. And that's where, again, benefits and the real benefit of renewable liquid gas, whether that's with renewable LPG and also with renewable DME, come into play. So away from industry, Chris earlier covered homes as well. Myself, I grew up in an off-grid area. I know the challenges firsthand of what it's like living in the midst of nowhere, quite frankly, and the different challenges that you face compared to when you live in an urban area. They are very different. And as someone who's recently moved to the Netherlands and now living in a city centre location, it really is even more apparent actually just how much it's quite easy to you take for granted the challenges that we're seeing in rural areas. So we've kind of gone through the issue at hand. We've gone through the need. So what are we specifically doing about it? So I wanted to talk about one of our first partnerships, which is a company called Circular Fuels Limited, who we've set up with a company called Q Technology. This is where I go into a bit of a joint venture, and I'll lose you all. So I'm not going to do that and just focus a little bit about what Circular Fuels are going to do. So Circular Fuels are using a process which is up on the screen that you can see here, where we take solid feedstocks. We're specifically taking municipal solid waste. We're putting it through a gasification and synthesis process, and at the other end, we're getting renewable and recycled carbon, DME. We have a demonstration plant that's going to be operational mid-2022 in the UK, located in Wednesbury at the Sustainable Energy Centre in Birmingham. And if anybody's had the chance or will ever get the chance to go, you should definitely go to see the great work that they're doing in Birmingham. But actually, what this is moving ultimately towards is our first, and to be honest, the world's first renewable and recycled carbon DME plant utilising waste being built in the UK. So this plant, there's a picture up on the screen that you can see here. This is an example of what it could look like. Gives you a little bit of a flavour. It is a modular system in essence, which means that it can be scaled up and it can be scaled down. So that's very important when we're thinking about other markets and how we go on to produce and reach our 300,000 tonne target. What we're specifically doing in Teesside is producing 50,000 tonnes of renewable and recycled carbon DME from municipal waste. To put this into context for the UK market, that's equivalent of about 5% of the total LPG kind of traditional market that we see. So it's very, very significant for one plant. If we actually break that down even further and actually just take domestic heating, off-grid domestic heating as one example, then that could equate to about 25%. So the impact that actually this one plant can have in the UK is quite significant. And I think as the whole industry, not just Dimeta, is scaling up in all of these aspects and new players are coming to the market, it's again, it's working to push that industry through the next milestone. One of the reasons that we picked Teesside, there are a number of different factors as to why the Teesside location in the UK was chosen, but one particularly interesting thing is that it's on how could I put it, a site which you can have access to CCUS in the future. So one of the things that we will be able to do is we will have the ability to connect to a CCUS system. And this will also help us to achieve negative carbon with the fuel as well in the future if we wish to. Also, again, with the system at hand, we're talking about something that is agnostic to feedstock and therefore flexible. Again, coming back onto discussions around things like energy security, whether you're in a rural area or not, energy security is all on the tip of our tongue with everything that is happening in the world today. So again, these driving factors become more and more important depending on how the landscape is changing. It was great to see ministerial support in the UK for this, also support from the mayor and other key influencers in this space. And it really has had that buy-in because there is a clear need and demand and want for a mix of solutions. As we look to the future and coming back to this point around Europe, subsequent plants in order to reach our 300,000 tonnes objective will be located across Europe and North America. So all I can say is watch this space. There will be more public announcements coming out on this in the near future. So if you're not linked up to us somehow on social media or following our website, then please do. But one thing for the industry, and Chris, you also touched upon the importance of innovation. And I'm sure we're going to go on to hear a little bit more from Rebecca as well now in terms of that innovative process that happens. We're looking at building more partnerships. So we're not just focused on one route and one feedstock to producing renewable and recycled carbon DME. For example, in October of this year, we went into a collaboration with a company called Enerchem, who you may have heard of. This is the first company in the world to produce renewable methanol and ethanol from non-recyclable, non-compostable municipal solid waste at a full commercial scale. So we're looking at exploring the developments of a different type of, different level of plant, different scale. We're looking at something that is circa 150,000 tonnes per year with a strong focus on maximising CO2 recycling. So again, we're looking to establish more partnerships, work with industry, work collectively, and able to accelerate the industry to reach its goals, which it's laid out with, and John, I'm sure that you will talk a little bit more later on in terms of the ambitions actually that the LPG industry have set out in terms of delivering a just transition to net zero. I'm not going to go on any further. This gives you a little bit of a flavour as to what we're looking to do in Europe, that really I think that as a sector as a whole, we're at the start of that journey. And I'm really, really excited, genuinely really, really excited to see that what can happen, not just in the next 12 months, but beyond. So I look forward to the rest of the discussion, and any questions, I will answer them later on. Thank you, John.
Thank you very much, Sophia. And as you said yourself, this is an exciting series of developments, renewable and recycled DME, not just in a presentation, but actually stuff happening on the ground. That's very exciting and very encouraging as well, and that's in Europe. And now I'd like to introduce you to Rebecca Boudreaux, who is the President and CEO of Oberon Fuels, who's going to talk to us about renewable and recycled carbon DME, new but old, a California case study. How exciting is that on a drizzly, cold December day? Thank you, Rebecca.
Absolutely. Well, good morning, good afternoon, good evening, wherever you sit in the world. It's exciting to talk to you about a California case study on renewable DME. And it's particularly exciting. I'm providing a perspective from the work that we've done over the past 12 years in California, but now actually as a US and an EU citizen sitting in Hamburg, Germany, where it's also rainy and drizzly. It's very fun to talk about California and what we've learned there, and really talk about how can we translate this to the European context. What are the lessons learned that we can build upon, even though we're in a different geography, but things that can be passed on to accelerate this transition. And so I want to start the case study, the timeline in 2010. And that was when Oberon Fuels was founded in California. But it's important, and I know Chris alluded to this in his talk, but this work that we have done is built on over 30 years of work that was done beforehand. And we're really standing on the shoulders of giants in innovation. And that's how innovation happens. People continue to iterate, discover new things. People take it to the next level and keep going. And so in the early 90s, just an example, a DME was already being used as an aerosol propellant, but Theo Fleisch and Ron Seals were some of the founders who really took DME and looking at it as a transportation fuel, initially as a diesel replacement, and then beyond that, LPG blending. And many people on this call were in the early days of DME. So when the Oberon came in, it's 2010, and you said, you see this, and this is California. People mostly think of the palm trees of San Diego, Los Angeles, the fog of San Francisco, the Golden Gate Bridge, but you get out of the side of the city centers, and there's a huge rural community in California. Very large agricultural communities, very large farms. This is actually our Maverick Innovation Center, where we produce the first renewable DME in the US, and across the street are 10,000 cows. So on a windy day, it can be a little rough, but this is a very agricultural community. So I think a lot of things can be translated amongst rural communities around the world. And our focus since then has been on developing innovative solutions to help countries, industries, and companies reduce their carbon footprint. And the main way we're focused today on doing that is through the DME molecule. And so when this journey started for us, we were really focused on technology, on production. But really, it became not just about technology and developing that and scaling that. It's also about regulatory development and market development. And so for the discussion today, I really want to focus on the regulatory journey, again, trying to flesh out lessons through the past 12 years of what we've learned that can be translated in the European context. And so when we started at Oberon, I joined the team when I was 5 months old. We had this interesting technology. We can make DME on a small scale, but we needed to be able to sell it. So we approached the regulators in California. We did searches online. We couldn't figure out how to register new fuels. So we approached the state of California, and they said, well, we haven't certified a new fuel since 1992. So we have to figure it out. How are we going to certify, be able to sell DME legally as a fuel in California? And so early on, we started engaging with the regulators, which I think is an important lesson learned, is that early on engagement, and then having a group of people who are willing to do the work on that. And in order to get DME to be able to be legally sold in California, a consensus standard had to be formed. And so the ISO standard was still in development. It had been for some time, and time was of the essence for us. So we worked with ASTM International and developed D7901, which is an international consensus standard on the purity of DME, how much methanol is allowed in their water and so forth, again, to set the standard on what would be allowed for DME to be used for fuel applications. This allowed the state of California to change their code of regulations in 2015. Then DME became legal to sell as a fuel in California. In 2014, also the US Environmental Protection Agency, the EPA, runs the Renewable Fuel Standard Program. And it's a very important program because it incentivizes the use of renewable fuels in transportation by giving incentives. They refer to them as RINs, renewable identification numbers. And biogas, one of the feedstocks that we use, was considered a feedstock and a fuel, but no one had applied for a pathway to convert biogas to something else and then be able to generate these types of credits. So in 2014, we applied for a pathway with the US EPA, and it was granted to us to get using Oberon's process to convert biogas to DME and to get credits for that. And those who live in the world of the federal RFS program, that's D3 and D5 RINs, which is all about the feedstock and the fuel you produce. So this is an important step as we started at the state level in California, at the federal level in the US, starting to check the box of what do we need to bring this fuel commercially, and going through this stuff. So, we're already 4 or 5 years in, we started in 2010, checking these boxes to allow the commercial sales of DME in the US. In 2018, we addressed another challenge in that the state of California, in addition to the federal credit system of the Renewable Fuel Standard Program, at the state level, California is one of just a few states in the US, Oregon and Washington as well. Other states are considering it to have a low carbon fuel standard. And it's similar to the federal program in that it incentivizes using renewable fuels in the transportation space. And California runs the low carbon fuel standard program. So you can look in a table, you go to their website and it says, you use this feedstock and make this fuel. This is what your carbon intensity estimate is, or here's a range. The challenge with the new fuel is that you're not in this lookup table. How will CARB, California Air Resources Board, do the math? And so we approached CARB again, with having worked with them at this point almost a decade, and said, okay, here's the latest challenge for us. Innovative fuel, we're not in the lookup table. Help us understand how you do the math. And so they looked at the Oberon process and said, okay, if you take biogas from dairy cows, so from their manure, you convert it to DME by the Oberon process, we estimate that it would have a carbon intensity of minus 278. So for many feedstocks like dairy manure, because the manure in the US is typically flushed into a pond, and then it releases emissions from there, by capturing those emissions with a digester and then converting that to a fuel, you actually end up with a carbon negative product. And this was a very important step because it showed, particularly for the LPG industry, that you could blend even only a 20% into the existing LPG product and get enormous amount of almost 60% greenhouse gas reduction with just a 20% blend by using carbon negative renewable DME from Oberon in there. And so the journey continues. And in 2019, 9 years in, we actually got our first public funding from the state of California. And they made an investment in renewable DME, which then also catalyzed additional funding from US companies, as well as on the international front. And it was important because it took an enormous amount of education over those 9 years to allow DME to be even able to compete for these grant funding opportunities, which is important, again, on the engagement, the education piece, and then also having supporter. So the gentleman, well, to my right, and hopefully yours as well, in the tie and jacket is Assembly Member Eduardo Garcia. He represented California, the district in which we're located, and he also sits on the board of the California Air Resources Board. So he was able to see from state level what can be done with emissions by using a DME product. But he's also able to see on the local level the opportunity that investing in renewable fuels and renewable fuel production, these types of projects, actually creates opportunities for the communities in which they operate. And this is here, one of our founders, Elliot Hicks, our COO and CTO, giving a tour to the California Energy Commissioner, Patty Monahan, the agency that awarded this grant, and touring the facility. And the investment by California of almost $3 million US, which was matched by an equal amount from the private sector, enabled upgrades to our existing facility, which first came online in 2013, to be able to process a new type of renewable feedstock. And in 2020, just a year later, we were able to celebrate on many fronts at our facility here. So we all know 2020 was marked by the COVID pandemic. And so here you see in the desert, our team still masking as required by regulations at the time. But because of the investments that the state of California made in our facility, we were able to offer jobs in the community in which we operated during COVID. And the time we were hiring in June 2020, that region was experiencing 27% unemployment. Half of the people that we interviewed were unemployed. And 1 in 4 people were testing positive for COVID. So a very dark time, but innovation and investments in renewable energy were creating opportunities for people to have jobs, family wage jobs, that they can support their family and have a great opportunity. And this is something that's not just in California, but it's around the world in rural communities. Later that year, the state of California actually passed legislation that enabled the equal taxation of DME. And so we're still masking at that point a year outside. And this was important because as DME pushed closer and closer to commercialization, we found more and more, we would find regulations that just need to be fixed. They were written, the rules were written for what was around at that point in time, not for the future. Again, an opportunity interface with regulators. And so Assemblymember Eduardo Garcia carried the legislation, which is signed by California Governor Gavin Newsom. It was one of 7 bills that were characterized as legislation that further advances California's climate leadership and transition away from fossil fuels. In 2021, as we continue on the timeline, the investments of California enabled the production of the first renewable DME in the US. And here's the team that was responsible for that, and many others, engineering team and others. It was very exciting to be able to produce renewable DME at the site through these innovations. But then there's more to come. And so we have a production pipeline globally of about 30 projects right now, building more renewable DME production, understanding the waste challenges in different communities, different geographies, and are targeting 200 million gallons of DME production per year by 2027. And these, again, on the regulatory front, as we push forward, we continue to engage with the California Resources Board, making sure these blended products, renewable DME and LPG, can be used under existing regulations. So engage with the fuels team to evaluate that, confirm existing regulations allow their sale. And then ultimately, just this year in 2022, renewable DME LPG blends are being sold in California today. So the US's 3rd largest LPG company, Suburban Propane, is blending in Oberon's renewable DME from the Maverick facility that you saw the photos of and selling to customers today. And those customers are using it on road in vehicles, as well as in forklift applications at the 4 to 5% blend level. And so excited to start to get renewable DME into a product. We're introducing renewable content and continue push forward. So thank you so much for your attention. Looking forward to the continued discussions, and I'll pass it on to the next speaker.
Thank you very much for that, Rebecca. Very interesting also, and very, very useful, particularly, outlining the journey that Oberon Fuels has had to go on to work closely with regulators, policymakers, to ensure that this exciting new fuel or old fuel from new feedstocks is both beneficial and safe. And you've obviously successfully done that in California and the US. And what I'm interested in, Rebecca, and if we could just have a little bit of a chat now, if you don't mind, about, what have you learned specifically from working with, the state of California, and perhaps what you learned, how would you use that to advise others, say, for example, member states within the EU?
Yes, a couple of things that I take away as key learnings. So one of them is early engagement. As I briefly mentioned, it's getting in early, being very transparent. Here's what we know. Here's what we don't know. How can we work together to fix this regulation or figure out the path forward? And when I joined the team at Oberon, we were very small, and none of us were from the energy space. We were largely technologists. So we had very naive and just approached California. I didn't even know what CARB stood for at the time, figured it out, but we didn't know the process. But we were willing to work with them. And so that early engagement and that ongoing conversation, which has now been 12 years, and then continuing to approach when there's another hurdle in the way of how can we address this? Here is the issue. I mean, the other side of that is, being willing to roll up your sleeves and get your hands dirty. At the time when we were doing this, it was only a small group of people pushing DME in the transportation space. And everyone who was involved was doing the work, writing the ASTM regulations, whether they were experts or not. They were great experts who helped us and pushed it forward, but the willingness to get involved in things that we weren't experts in, but were able to find experts. So I think that early engagement with regulators, as well as the companies involved, really being willing to get their hands dirty and be part of it is very key.
Thank you. Thank you for that. So transparency and early engagement. And, you know, the journey that you've been on, I think, did you say started in 2014, 2015?
2010, early
2010.
on, we approached California, so very early on.
Yeah, so this takes some time, and we all know that time is not really on our side because we need to make significant improvements between now and 2030 and 2050. So anything that you've learnt is very, very valuable to us over here in Europe. So another question then, very, very closely related, and that is, we talked about California and the state of California encouraging Oberon Fuels to develop renewable DME. What about the US legislative environment, you know, that is there to support the development of renewable liquid gases? If it's there, and if it is there, how does it do that? Have you got any comments on that, Rebecca?
Yes, I think two of the key regulations historically have been the renewable fuel standard at the federal level, and then the low carbon fuel standard in a few state levels. And one of the keys is on legislative certainty. So you build these projects, and Sophia and the Dimeta team can attest to it, and others. These are 10, 15, 20, 25-year projects. And when you model them out, and the key component is on incentives, the incentive lasts 1 year, or it has to get renewed in 3 years. It's very difficult to model. And the people who are putting the money and investing essentially discount it if there's not some level of certainty on that incentives. So having the regulations in place and also providing guidance on how long that they will last is very important to build these projects, because large investments are being made. And so that's very important. Recently, in August, the US Congress passed and the president signed the Inflation Reduction Act, or the IRA. And this has created a huge amount of momentum and spaces in renewable gases, but also, you know, Oberon, as Chris mentioned, is looking at DME as a hydrogen carrier. So again, leveraging the global LPG infrastructure to move renewable hydrogen. And so all of these different types of fuels are incentivized further. And so this is very important to get large investments that are needed. As you said, we don't have much time, and to help this transition happen as quickly as possible.
Okay, thank you, Rebecca. So what you're saying is, you know, legislators need to create the environment that will enable industry, business to invest in the development of these exciting new fuels. I'm sure legislators get told that all the time, but it's worth repeating it, I think. So thank you very much. Thank you very much for that, Rebecca. So I'm now going to move on to Chris Goggin from Rinnai, who's going to talk about how liquid gases and renewable and recycled carbon DME can contribute to a just and realistic transition. So over to you, Chris.
Okay, no problem. Is that sharing okay?
Yeah, all good, Chris. Thank you.
Great, thank you. As John mentioned, my name is Chris Goggin. I am a director at Rinnai UK, which is a part of the Rinnai Corporation. It's a pleasure to speak to you all today, and hopefully we can give you some insights on what we're doing and how that can have a positive impact on decarbonisation. I will discuss the potentially strong role that renewable fuels, such as renewable and recycled carbon DME, can create from, which is very important to me and us as a company, is the practical, technical and economic routes to a decarbonisation pathway for both heating and hot water generation off the gas grid. The role that can play in reducing carbon, whilst also being reasonable and realistic in terms of the energy demand, our power systems, our infrastructure that we have in place, and how that can really act as a vehicle to deliver what John mentioned as a just pathway. So in the very limited time that I do have available, the presentation will highlight the benefits of a transition from carbon-rich fuels like oil and to a lesser extent LPG, to lower carbon liquid fuels and specifically renewable and recycled carbon DME. I will give an overview of what we do, a short introduction, then we'll look at some of the applications in terms of like hot water schematics, and we'd have to consider how that is actually scalable across different applications and isn't particularly prescriptive to just one area. And also we'll focus on the conclusions around carbon, technical, practical, and economic feasibility when we install these systems and applications, and the importance of considering those. This is a short format presentation, so my details are at the end, including LinkedIn for anybody who wants to get in contact over calculation methodology and the way we've gone about these things. You're more than welcome to do that. It's probably important that I do introduce my company, and that is the Rinnai Corporation I mentioned earlier. We are suppliers of high efficiency, gas-fired water heating equipment, boilers, electrical equipment, and heat pumps. So we've been preparing for the future in terms of, from a technology perspective, from both electrical, electron, and molecule. Our global brand promise is to create a healthier way of living. And we're investing a lot of our turnover into R&D for renewable gases like hydrogen, RDME, and also electrical equipment. So we can be considered somewhat technology agnostic in this debate. And I think that's an important consideration when we look at the technical, practical, economic, and carbon intensity of a range of applications. So, in our view, there is potential for renewable liquid fuels to offer an economical alternative to heat pumps and conventional electric and oil-based systems. Where heat pumps could help decarbonize buildings off the gas grid, there's been multiple studies, including one by Liquid Gas UK, that's shown about a third of homeowners would not be able to afford a new heating system at any given price. Heat pumps can be very expensive and are somewhat beyond the reach of certain demographics and business owners, and conventional electric heating is not recommended for certain archetype buildings, as we've seen in multiple studies. Oil and LPG have historically had similar costs. However, more importantly, LPG offers considerable carbon savings when compared to oil-based systems. It's also worth mentioning at this point that the same appliance can be operated on LPG if we were to convert over to bio-LPG or a blend of LPG and renewable liquid fuels, thus eliminating the need for replacement equipment, technologies, upheaval of pipework, downtime, additional costs caused by remedial works, and enabling a smooth and potentially cost-effective transition from LPG to 100% renewable liquid fuels in the future, whilst also having a fairly profound impact on carbon throughout that journey. The list here is not a prescriptive list, but we come across these on a fairly regular basis when we're talking about the solutions we offer. And most of these applications shown in this slide would struggle without the gaseous fuel. I mean, for instance, if we were to consider a campsite off the gas grids, it would be incredibly difficult to replace the LPG water heating system by going all electric. We'd put a lot of pressure on the battery and the electrical infrastructure around that area. Typically in this environment, we would be talking around 200 kilowatt of gaseous appliances just for the ablution blocks. When you add to that the need of supply for cooking and other electrical equipment, you can see it has quite a huge draw on some of these off-grid energy infrastructures. Another area that we do a lot of work on at the moment is in the dairy farming sector, which is a high volume, high temperature application that would be required a high volume of storage, probably in the format of electrical storage, which would create practical and economic issues for a lot of people we've spoken to. So we need to be thinking about alternative applications away from all electrification. And this comes from high hot water temperature requirement, high hot water volume requirement, system performance, and requirements for ancillary heat sources, particularly when we talk about hot water requirement. So if we were to just look at a sort of very basic schematic of the way we would set up a gaseous system, the schematic is one we've done recently for a modern dairy and robotic milking equipment agricultural site. The system supplies the hot water for the milking requirement. The milking requirement needs extreme high temperature of 85 degrees for bacterial pasteurization. The flow rate is very high. We would need about 116 kilowatts, dependent on specification. And we would do this instantly with no storage requirement. The water passes through the system, heats it instantly, and puts it to the outlet via instant heat that's provided on site in a relatively small footprint. The working principle shown is it just passes through the LPG, bio-LPG, and a renewable and recycled carbon DME blended system, because there'd be no requirement to replace it, direct to outlet, without being prescriptive over what blends are going to happen, because that's not down to me. But if we were to look at a renewable and recycled carbon from municipal waste blended with LPG in a format of 80-20, which is quite often discussed, we could expect to see a carbon reduction of 14.5% from the LPG by just having that system transition to the blended fuel. There would be no need to replace any of the hardware or update any of the system requirement, but it would decarbonize as the gas decarbonized. Clearly, as we extended that with greater biofuel, we would see that carbon emissions fall. And an interesting point at this juncture is an accepted or a widely accepted route to decarbonization is hydrogen blended with methane at the same ratios at 20/80. That would have a 7% reduction in carbon. So this route actually has a greater carbon intensity reduction, very similar blended volumes. So if you've looked at that from a carbon intensity perspective, you can see that practically we can reduce carbon with a very pragmatic route by defossilizing the fuel. If you begin to look at it from a hardware perspective, you can see the fundamental differences between replacing a gaseous system on the left-hand side, which is an appliance with hot water in, gas in, hot water out, to a heat pump with a primary cylinder and a secondary cylinder to increase the temperature of the hot water to the required volume. This begins to illustrate practical and economic feasibility of switching away from an in-situ gas system to an electrical system. As you can see, you would need the secondary heat sources, a significant increase in hardware, whilst also being considerate of the pull on the system in terms of energy. So one of the things that we would like to, or we do like to measure when we begin to specify gaseous systems, hybrid systems, or heat pump systems is how that's reflected in life cycle and CapEx costing. So we were to compare the fiscal/financial impact of the previous schematic. The systems that often the clients, the biggest reduction in carbon, the biggest reduction in expenditure would be the gaseous system down here. When you're moving up to the all electric, over the lifetime of that, it's a lot more expensive in terms of running and CapEx costs. A lot of that is held in the capital expenditure, but over its lifetime, the system is a lot more expensive. So therefore, when you consider this gaseous scenario, a very pragmatic solution, when you consider that from practical, technical, and economic feasibility, is again to reduce the carbon of the gas going into that system. So as stated in the report, and where LPG is used within the incumbent water heating and boiler, and it's still used in the future with blended or renewable liquid fuels is available, this would use the existing infrastructure, the heating technology, which would lead for the potential for both capital, operational expenditure savings for both the end user, whilst also having a pragmatic decarbonisation pathway of lowering the carbon intensity of that system. Renewable and recycled carbon DME is not seen as a solution to decarbonise the heating in the EU. However, this can play a significant role for areas with poor or moderate insulation, or where technical, practical and economic feasibility issues for all electric and heat pumps are prevalent. I hope that this very basic overview from these angles gives you an insight into what can be achieved by defossilising the fuel and using the existing infrastructure. As I've mentioned, you can contact me on LinkedIn or directly via my email to discuss any of these factors anymore, and whether we can do some carbon calculation and CapEx modelling for any sites that you may or may not have in mind to see what that impact is across a range of electric, gaseous and renewable fuel technology. Thank you.
Thank you very much for that, Chris. Probably you could call that a view from the coalface or the front line. So the issues associated with making use of renewable and recycled carbon DME, and three things I took from that, three phrases: a pragmatic solution, a just transition, and let's use existing technology where we can. So three very important things, I think, there. Chris, thank you very much for that. I'd just like to mention that at this moment in time, according to my colleague, you should be able to take part in a poll which is going to ask you questions about specific applications where you think renewable and recycled carbon DME might be particularly suited. So if you could take some time to respond to that poll, that would provide us with very useful information, and we will appraise you of that at some point once we've collated all the results. Okay, so moving swiftly on, I would now like to go back to Christopher and ask Christopher if you could give us your thoughts, your perspective on the legislative landscape which could support renewable and recycled carbon DME, specifically in Europe. Christopher, if you wouldn't mind saying a few words on that subject.
Certainly, thank you, John. First of all, I just wanted to say that the experience and the pathways outlined by Dr. Boudreaux in California are certainly illustrative and very relevant to what we're attempting to do in Europe now. Certainly the landscape, the regulatory and legislative landscape in the EU is now arguably dominated by the European Green Deal. You'll know, of course, that the EU seeks to be a global standard setter in terms of climate GHG reduction, and the Green Deal is its vision for a climate neutral European Union by the year 2050. The European Green Deal is packed with 50 plus initiatives. I'm going to focus on 4 of them, which are, we think, most relevant in the near term to DME and its potential success in taking advantage of programs, projects, and initiatives in the EU. The Green Deal is, well, if you've read it, it's 24 pages, and it lays out a very radical project to make the EU climate neutral by 2050. It covers every aspect of society and the economy, including goals for biodiversity and agriculture. But at the center of it is a set of legislative proposals known as the Fit for 55 package, Fit for 55 refers to the EU's target of reducing net greenhouse gas emissions by at least 55% by the year 2030, aiming to bring EU legislation in line with the 2030 goal. So the four most relevant items in this package that we believe are the Energy Taxation Directive, the Renewable Energy Directive, Alternative Fuels Infrastructure Directive, and the CO2 standards for cars and vans. I'm going to highlight in just 2 or 3 minutes each of the takeaways from each of these. First of all, the Energy Taxation Directive, or ETD, the main provisions are simply to set the minimum levels of energy taxation for energy products used as either motor fuels, heating fuels, and electricity. It also would cover exemptions, tax exemptions and reductions. Its relevance to DME is simply would be setting the minimum tax rate for DME, which is obviously very important. And it's something that Dr. Boudreaux outlined in terms of California, something they were able to achieve with legislation in terms of setting the tax in a proactive way in the state of California, allowing them to produce and sell DME legally. Secondly, the Renewable Energy Directive, or RED, the main provisions are simply the general target for renewable energy, which is currently 32%. It has targets in various sectors, including transport, heating. It also defines renewable energy, and also the sustainability and GHG emission criteria, its certification and its verification. Its relevance to DME is the definition of renewable DME, first and foremost. It would include an update of production pathways and default emission savings values, these metrics, and also the criteria for sustainability and certification requirements that renewable DME would have to comply with. Thirdly, I mentioned the Alternative Fuels Infrastructure Directive, or AFID. The main provisions of this are requirements for the member states to develop national policy frameworks for the market development of alternative fuels and their infrastructure. It would also help define alternative fuels for transportation as a substitute for fossil oil sources. And it would also, we would hope it included DME as an alternative fuel in the list of alternative fuels and their definitions. The relevance for DME is related to any future DME fueling and dispensing infrastructure, and also the inclusion of DME in the alternative fuel definition. And lastly, I mentioned the CO2 emission standards for cars and vans regulation. This has gotten a lot of attention over the last 6 months, a lot of back and forth between a number of European associations representing the motor industry and all sorts of downstream applications, which are, I think, are seeing how much progress the electrification lobby has been making. The main provisions of this are simply EU-wide fleet CO2 emission targets applying from 2020, 2025, and 2030. It would include a mechanism to incentivize uptake of zero and low emission vehicles, and would also levy penalties when the average CO2 emissions of a manufacturer's fleet exceed its specific emission target in a given year. Lastly, the relevance for DME for this regulation would be that DME could benefit from a new crediting mechanism for renewable and low carbon fuels and gases. That was a very high level and very rapid overview of the 4 items that we think within the European Green Deal are most likely to bear fruit. And we're advocating right now within the association, within the EU, and meeting and advocating directly with some of the senior legislators and decision makers in Brussels on these topics.
Okay, thank Thank you very much for that, Christopher, for that outlining the legislative issues and files currently in the EU. Very, very useful. I'm now going to move on to some questions. Hopefully, this gets a bit more challenging for our speakers here. I've got a series of questions, and we're also getting questions in from participants, people taking part in the webinar and listening to what you've got to say. So here goes with the first of those questions, and I'd like to direct the first one to Sophia, if I may, Sophia, and then once Sophia's answered, if Rebecca could also answer the question. So what are your estimations about renewable? So what is your estimation of renewable and recycled DME production? So what is your forecast for the likely production of renewable and recycled DME, Sophia?
Well, I mean, I think there's a huge amount of opportunity for DME being produced both from renewable and recycling carbon feedstocks. If we're looking specifically at what we're doing at Dimeta at the moment, again, looking at waste, if it may be useful to put it into context that for the 50,000 tons of DME that we're producing at Teesside, that's using between 200 and 250 KT of waste that we are getting locally in the UK, and that is very much in terms of sustainable, in the sense that it's sustainable in the long term as well, in terms of accessing that feedstock, as well as the kind of sustainability criteria or requirements that there currently exist around waste as well. When we're looking at other markets, the same goes for this. So for all the markets that we're looking at, feedstock sustainability and availability is at the heart of the decision-making process. So that's, again, incredibly important to us. Not something specific to us, but something that I know that has been done at a global level. I know there has been various bits of research and studies that have been done by third parties, kind of independent to the industry, that showcases there's a huge amount of opportunity for production. I think that a conservative figure was even showcased at 39 million tons and maybe even beyond. And that was just one example to put it into context. What I would say is that I think there's a lot of great work that's going on with the International DME Association, yourselves at Liquid Gas Europe, and also at the World LPG Association. So I think that certainly watch this space, because I think there'll be more being shared in the coming year.
Right. More feedstocks you're talking about, Sophia.
Yeah, and also it ties into the production pathway, because that's where things like power to X processes, for example, become very, very interesting as we look at the long term. Maybe not for today, but certainly as we start looking into the 2030s and 2040s, and as these technologies develop, there's I think it's not linear. It's constantly changing. So they need to be quite agile in thinking about feedstocks and technology is really important, not just in our sector, but beyond.
Sure, but municipal solid waste, there's a lot of it about, as you said, and it's an issue for member states to dispose of it. And what you're doing is turning it into a very useful renewable liquid gas.
Yeah, and that's why we advocate for the recognition of the conversion process in terms of the waste hierarchy. So of course we want things to be recycled as much as they can, reused as much as they can. It's in everyone's interest that there isn't a huge amount of waste consistently available, for the long run. But there is always going to be waste available in one guise or another. And again, that's why waste is a particularly interesting feedstock, but it's not the only one of interest.
Yeah. Great. Okay. Thank you very much, Sophia, for that. Very, very interesting. And Rebecca, would you like to attempt to answer that one as well? What you see as the potential for renewable DME and interesting feedstocks going forward?
Yeah. So from the Oberon perspective, we are targeting 200 million gallons of renewable DME production by 2027, and so that's at the Oberon level. And I think one of the really interesting things that we've touched on bits and pieces in the webinar is that DME can be made from many feedstocks. And that is really important as we look, we've talked a lot about rural communities in the webinar today. And I saw in the question someone was asking, well, what about the urban centers? And you're right, the urban centers also need to decarbonize. And so the waste in the urban centers are going to be more municipal, solid waste, food waste, wastewater, treatment gas. All of these are feedstocks for DME. So anything that has carbon in it, essentially. So if you take any organic matter, it decomposes into a biogas under the right conditions. So that's methane and carbon dioxide. That can then be chemically converted to DME. You could go one step down the chain, make a syngas, carbon monoxide and hydrogen. That can come from gasification, municipal solid waste. That can come from trees. So, areas where I know in California, there's a huge issue with a certain type of beetle killing a lot of trees. And then you have wood waste, forest fires. So, again, a problematic issue that you could turn into something valuable. And then also methanol. And you hear a lot about renewable methanol being used in the maritime industry now. But renewable methanol is the precursor to renewable DME. So any of these types of compounds can be used to make DME and can be based on the feedstocks that are found in that region, whether it's rural or urban.
Right. Okay. Very interesting. So a wide variety of feedstocks you can see that can be used to produce renewable DME. And I think, Sophia, you were talking about a forecast of, did you say 39 million tons? I think potential, is that the potential?
I think that's a figure that has been quoted.
Yeah. Yeah.
Not
so,
obviously that's not specific to us. That is more generally for the industry. I haven't got that much of an announcement for today.
So we can. Okay. So a lot of this very useful fuel can be produced from a wide variety of feedstocks using a variety of different production technologies. Very, very interesting. So it's not one solution, it's one fuel with lots of different routes to produce that useful fuel.
Yeah. Yes, definitely. And I think that's very similar to the previous messaging around renewable liquid gases more broadly. And having that that mix of routes, and therefore there's not one reliance on one particular technology route and one particular feedstock, and with that is beneficial for energy security as well as many other things. Yeah,
great. Okay, thank you for that. That's clear. So I just I have another question here, and we've had a couple of questions from people taking part viewing the webinar online, and this relates to the compatibility or the ability, if you like, to mix DME with LPG. And there's been talk about this a blend ratio. What is the blend ratio at which you can basically use this combined fuel as a drop-in as a drop-in replacement for, say, LPG. So what percentage is that? And you might not be able to say specifically, but approximately. So Sophia, Rebecca, or even Chris or Christopher, to differentiate you by using two variations on your forename. Would anyone like to comment on that, about the blend ratio and the compatibility of LPG with DME?
I think.
Chris? Sorry, Sophia, go on, Sophia.
No, I was just going to say that I think it's great to see the questions that have come in the Q&A box. Yeah. And the guidance that you can see, in terms of the figures that are quoted so far, like relatively publicly, just like on the fact sheets, I'm sure Chris was probably going to mention, and I jumped in on, is that it's an up to 20% blend, and that is again the main figure that is being quoted at the moment, and it is very much, again, I think when we talk about the LPG sector and how we're looking to provide renewable liquid gas solutions to help decarbonize off-grid energy applications, it's about the drop-in. So again, that's where the up to 20% figure comes into play as an approximate. I know there is a huge amount of work going on within the sector, and that a lot of people on this call and off this call as well are contributing to. And I believe that there will be more further information is going to be shared on this activity in a much more formal way than kind of anecdotally on this webinar. That will be of great interest to a lot of people who are signed up to the webinar, and also to policymakers as we look to the upcoming legislative files.
Yeah.
And just to add a comment to that, so there's the question, material compatibility comes up, right? And so that's typically the 20% threshold. And so as you look at, when you're looking at engines, so on-road and off-road applications with engines, so it's important to remember that propane or LPG is a great spark-ignited fuel. It has very high octane number, and then DME in its pure form is a great cetane fuel. It actually typically has a higher cetane number than diesel, so excellent diesel replacement. Now you blend the two, so DME, if you blend it in with LPG, will bring down the octane level. And so it's important on engine applications that you stay above 87 octane. And in forklifts, they're often tuned to 87 octane, so you're fine around the same threshold as a material compatibility. If an engine's been fine-tuned for the use of LPG auto gas, then they may need to tweak the software. So that's an important nuance on when you start to look at on-road and off-road applications.
Okay, thank you, Rebecca. Did you want to add anything, Christopher or Chris?
Yeah, I wanted to add just one comment, and that is, this is first of all, the benchmark, the 20% blending is a benchmark long established, and some of the earliest work 20 years ago done by the Japan DME Association, which was a consortium of some of the world's largest companies operating out of Japan, millions of dollars or euros or pounds spent on this. These are well established and well known, and there's lots of literature backing this up. However, there's an enormous amount of work now going on. The World LPG Association has a committee which is deeply involved in some work related to blends. Other associations are working on it. And of course, the commercial partners, the commercial companies like Oberon Fuels, like Suburban Propane, like SHV, all doing work right now. Not all of it's been shared, but this is simply an ongoing matter, kind of finely tuning some of the information and data around blending. But the 20% blend benchmark is long established.
Okay, thank you very much, Christopher. Very interesting to hear those comments on the blend ratio and the benefits associated with blending. From what you mentioned, Chris, the 14.5% reduction in greenhouse gas emissions from blending renewable and recycled carbon DME from municipal solid waste with LPG, which is higher than that which you get from blending hydrogen within natural gas. Greenhouse gas emissions, obviously very, very high up there on the agenda. But what about air quality? Because that's also very high on the agenda, and the EU, as you all are all aware, has a zero air pollution or zero pollution target. So, you know, what's the air pollution, you know, characteristics of renewable and recycled carbon DME? How is it better than that which we're going to you know, replace it with? Would anyone like to answer that? Christopher?
I don't think it's a willingness of anyone to answer. I think everyone's too polite to go first.
I think you've already referred to it in a presentation, but would you like to go over that again, perhaps, Christopher?
Certainly, I was going to defer to Dr. Boudreaux simply because of the data and the metrics that came out of the California Energy Commission and their practical work on the matter.
Okay.
Yeah, so if you know, we were talking a lot about the life cycle analysis, so we'll look at emissions in a few different ways, right? And so with California Resources Board, you know, the low carbon fuel standard, they talk in carbon intensity, right? And so in the US, gasoline and diesel are 95, 96 grams of CO2 equivalents per megajoule is the threshold here. I mean, everything's set from a benchmark there. And that's where DME, depending on the feedstock, can be low carbon, you know, 40, 45 grams of CO2 all the way to carbon negative. So minus 200, minus 300, again, depending on the feedstock you use. So there's great resources in the US. Argonne National Lab published a paper on their GREET analysis of DME. In the EU, I know there's been some excellent studies done as well. So everyone has slightly different benchmarks and different measures of calculations, but that's on the greenhouse gas reduction. All about the feedstock, very low carbon to carbon negative. As we think about air pollutants and air quality, a lot of the early work done on DME as a diesel replacement indicated that DME produced no particulate matter when used in heavy duty engines. And that was a lot of the work that was led by Volvo and others doing that. So generate no particulate matter, which enabled it to be easier to control the NOx levels as well. So that's on the diesel replacement side. So there are a lot of benefits on multiple levels as you look at using DME from the emissions perspective.
Okay. Thank you very much, Rebecca. So I now just like to move on to another topic, and one of the participants has asked a question. Really, has asked a question and posed this, made a suggestion at the same time. One of those is what is the sector? What does the sector need? What is it looking for to develop, further, the availability of renewable and recycled carbon DME within the European Union, and also secondly, and have you as individual organizations, have you considered Horizon Europe life projects for pilots and demos, perhaps in, I know Sophie, you've already talked about the pilot plant in the Midlands in the UK and the production plant in Teesside, and Rebecca, you've got a plant in I think it's California, am I right in saying, of course. So what does the sector need, and how can we develop this further and more rapidly in the EU? So a question really for Sophia and Rebecca, really. What do you need? What do you need?
Shall I go first, Rebecca? I'll take the
Take up the challenge.
So I think in terms of what would we like and what would we like to see, and maybe without getting into the specifics of specific funding programs, I think firstly it comes to the market as well as the fuel, but also the market, the application. So I think ultimately the recognition at a European level and filtering down into the various member states as well, that there is a need and an opportunity for renewable liquid gases to play a role in that energy mix is critical, because at the end of the day, that is the end goal for where this fuel is going, regardless of the specific applications themselves. So I think that's first and foremost critical. When it comes to the actual the fuel itself, and this is probably maybe a little bit more specific to us with the recycled carbon element, but we would also want to see kind of further developments in and around the recycled carbon fuel space. We want to be able to see that, the recognition that there's obviously a huge amount of opportunity in transport, but also again in the heating space. And I think it all does eventually just circle back to this fact that there's not a one size fits all solution for off-grid energy. There needs to be a multiple selection suite, let's say, of solutions. Electrification is going to work really well for some of them. It's not going to work for others.
Yeah, unfortunately, I don't know about yourselves, but I've lost Sophia for a moment. Would you like to take up the reins, Rebecca? What do you need?
Yes, so I go back to the California case study to show, parallels, the importance of regions and countries investing in innovation is important. And so seeing California's investment in renewable DME was followed on by private investment, not just for that project, but for us, it brought in a new shareholder, a major LPG company, Suburban Propane in the US. It's led to working on investments in the next productions facilities, as well as continuing to use renewable DME and LPG blending, but also in the renewable hydrogen space as a carrier for renewable hydrogen, building upon that. And that was all because of the less than $3 million US dollar investment from California. So inclusion in grant projects, and also the importance of technology neutrality, setting the target of, we want to hit this greenhouse gas reduction or this carbon intensity score. However you get there is less important than just meeting the target, because we had challenges along the way of the winners already being picked. And so just being open to innovation, because the next cool thing we probably don't know about yet, right? 5 years, 10 years, 20 years down the road, and writing policy as much as possible to make sure that innovation as it continues to evolve is included and eligible for funding opportunities and not excluded from these areas.
Thank you very much, Rebecca. Very useful. So, unfortunately, with many questions from participants left in our inbox, we unfortunately have come to the end of this 90-minute webinar. I'd like to thank you all for your time and your contribution. It's been very useful, very interesting, and we will be following up on this with questions for you. We would like to provide to those people who've asked those questions. Thank you very much once again. Any last words, Rebecca, Christopher, Chris? You've got
Thank you, everyone,
5
for
seconds.
your attention.
Say again, Rebecca.
Thank you for your attention. We appreciate you joining today.
Okay.
Yeah, thank you very much. And we're looking forward to Liquid Gas Europe being our newest strategic partner beginning tomorrow, I believe.
Yeah, likewise. Okay. Thanks, everyone. Thanks for your time. I'll say goodbye.
Cheers.
Thank you.
Bye-bye.
Bye.
Thank you. Bye-bye.
Bye.